Shut up and sit down.
Well, hey everybody, welcome to our 2020 National Electrical Code series here on Patreon. And we're excited because we're now getting into the parts of the code which are, to me, fundamentally critical to understanding the rest of the National Electrical Code. And that's Article 100, definitions. So previously, you've watched our videos in this series where we talked about Article 90, and we learned about the scope and the purpose of the NEC. We even learned about the structure of the NEC. We even learned units of measurement of the NEC. And now we're moving into Article 100, which are definitions. Now, definitions are critically important because understanding definitions helps us as we move through the National Electrical Code. There's many areas in the code where it uses terminologies and references that we're going to be confused about. And so we could go to Article 100, and Article 100 gives us those basic definitions that if you understand the structure of Article 100 in the NEC, it says that, look, if I've got a definition of something that is general, that's used throughout the NEC in multiple or more than one article, then I'm going to put that definition in Article 100. Now, if it's only used in one specific article, very specific to that article, then it'll put a definition. For example, the definition of EMT, electrical metallic tubing, is going to be under the .2 section of its required code, 358. So it's important we understand the structure and what goes into Article 100 because it is very broad. Now, understand that not all terms electrically are covered in Article 100. So there are definitions that are held in the Manual of Style. There are definitions that are actually the college edition of the Webster's Dictionary that you can use that gives us that direction from the Manual of Style and all that kind of concepts. And there's other documents from NFPA that gives you kind of a definition backbone. But we're going to focus on the definitions that are important to us inside of Article 100. So let's begin that journey and look at it. So here we are in Article 100 of the 2020 edition, Chapter 1, and we're talking general. Now, definitions. This is interesting because we want to look at the actual scope. And we always say that because this is broken down into three parts. Okay? And when we're dealing with the scope, it kind of gives us that foundation of how the definitions are going to be broken down. It's going to save you a lot of time. So let's look at it. And anything that you see that is highlighted is a change from a previous edition. When you see the triangles that are highlighted in the actual columns in the side, that lets you know that something was deleted or changed from a previous edition, so you pay attention to that. Okay, if you see a dot anywhere, that means some section was removed from a previous edition. So that's kind of the way it lays out when you're looking at the 2020 National Electrical Code. All right, so let's look at the first thing we want to look at. And what I'll do is I will try to adjust this a little bit so that we stay focused on the definitions as we move through it. Okay, and I'll try to always keep myself out of the picture as best as I can in order to convey the message, okay, moving forward. All right, so let's look here. The first thing we're looking at is the scope. What is the scope of Article 100? It says this article contains only those definitions that are essential to the application of this code. This is not intended to include commonly defined general terms or commonly defined technical terms from related codes and standards, okay? So it's only dealing with the definitions that are germane to this specific code, okay? The National Electrical Code, in this case, NFPA 70 is the document, okay? It says, in general, only those terms that are used in two or more articles are defined as Article 100 definitions, okay? All right, so basically what we said earlier is if I've got a certain term that is used throughout the code in more than one article, in order to keep things uniformed, we're going to move that definition over to Article 100, okay? So it could be a definition, for example, arc fault circuit interrupter, that originally started in 210.12, and it had a definition in 210.2, but it started to broaden itself and get used in mobile home applications, so it had to broaden itself. So once it started getting a term that's used in more places, then, because now we have arc fault circuit interrupter that's used, for example, in PV system. Once we started doing that, we then had to take that and actually put it over into Article 100. So you'll also notice as you go through the code, and we'll read the rest of the scope here in a second, but you also notice you have these brackets or these parentheses that actually talk about, for example, CMP1. When you see this through here, it lets you kind of know who is actually in charge of that definition, okay? Who has the order of charge in order to make sure that that definition is current and it's looked at by that code making panel. Now, as you go through this, you'll see some of them, for example, if it's a grounding and bonding term, that'll still say code making panel 5 or CMP5. That means that the definition has been revised and ratified by code making panel 5, and they submit it to be installed in Article 100 to code making panel 1. But code making panel 5 still takes authority over that definition. Okay? They still own that definition itself. So in a next subsequent cycle, they could modify it, they could supplement it, they could change it in any way, and that's generally done by them. Okay? Not done by code making panel 1. Okay? So that's how we look at that. All right, so let's finish up our scope. It says part 1 of this article contains definitions intended to apply wherever the term is used throughout the code. So all the definitions that we're going to see and kind of briefly look at are part 1 definitions. They apply throughout the NEC, everywhere. Now, we also have a part 2. And a part 2 is only going to pertain to installations and equipment that are operating at over 1,000 volts nominal. So all of those installations that are over 1,000 volts, and you have those definitions that are in part 2, they are going to be very much driven towards the over 1,000 volt application. Okay. Now, something that's new for the 2020 National Electrical Code is a part 3 that's been added into the definitions. And that contains all of those definitions that pertain to hazardous classified locations. Now, prior to the 2020 code, the definitions were intermingled in part 1, and they were all over the place. And also up in Article 500, you had a dot 2, which also had additional definitions. And some of those things might have been very specific to that article. But the problem is a lot of times in that dot 2 of 500, you had the terms used in 501, 502, or 503, obviously used in more than one article. So they had to come and get over here into Article 100. Now, how do you put that together so that it is well formulated and all of the terms that deal with things like dust proof and things like that? How do you do that? Well, you come up with a part 3 and you put all of those definitions that pertain to hazardous classified locations in that area. And that's what they did here in the 2020 revision. We also should remind you right here that definitions are also found in dot 2 sections of other articles. That is very true. Example that I gave you at the beginning, EMT, there's a dot 2 section that gives the definition of EMT. And so again, now, does that get used in other articles? Absolutely, because you have that wiring method might be referenced. So another change that took place in the 2020 code was that they made some statements that said, okay, it's being used in this article only, or it'll say it's used in other articles as well. But that's just telling you that dot 2 takes the dominance on the definition. But just so you know, this term might be used in other parts of the code, okay? So you have to pay attention to that. So you still have your dot 2 sections in specific articles, but you also have, anytime it's used in 2 or more, it's going to be over here in Article 100. So just kind of remember how that flow works as you move through it. All right. So let's kind of move through a little bit and look at some here. So this is part 1. This is general. And we have what's called accessible as it applies to equipment. And when we see that, it means, is the equipment accessible? Okay. Not accessible to like a wiring method, but the equipment itself when we see that in the code. So is something accessible? We have 2 different applications here for accessible. One has to do with equipment, and then one has to do with as it applies to the actual wiring method. All right. So you see a change here. This is all grayed out. So it says, what is accessible? The definition is dramatically simplified, and it says Something's considered accessible if it's capable of reaching it, being reached for operation, renewal, and inspection. Now, there's a difference between something being considered accessible and something that has to be readily accessible. And that's a definition we're going to look at here in a second. But there's a difference, and you need to understand the difference. So the National Electrical Code will give you applications like panel boards, and it'll say that they have to be readily accessible. We have to get to the overcurrent protected device and things like that. So that's a little different. I can't put things in the way that can block my ability to get to it. I can't climb over, climb under stuff. I can't resort to ladders and all those things, because at that point it would not be considered readily accessible. A good example of this, and we haven't looked at that definition yet, but a good example of this, so you can kind of hammer it home, is that in garages, all receptacles have to be GFCI protected. And now, with the changes in the 2020 code, it's no longer just 15 and 20 amp receptacles. It's expanded, okay? And we'll get to that when we get to that area of the code. So all receptacles that are installed in an actual 50 amperes or less, that are 150 volts or less to ground, and that are 125 through 250 are going to require to be GFCI protected. So we're in this garage, let's say. If somebody put a GFCI receptacle in the ceiling that controlled, because maybe the home run hit the ceiling and then hit all the receptacles that you might put in the garage, you'd have a problem, because putting that GFCI 210.8 says that it doesn't just have to be accessible, that it has to be readily accessible, okay? And so there is a distinct difference. Accessible means I can walk right up to something, I'm not obstructed, push it, reach it, get to it, not a problem. Readily accessible means that, okay, I can't resort to certain conditions in order to be able to get to it quickly, because I need to reach it very quickly, all right? All right, so we'll look at that when I get to readily accessible here in a second. We'll hammer that home again. All right, so then you have what's called accessible as it applies to the wiring methods, okay? So it says what's considered accessible when we're talking about wiring methods, and those would be wiring methods that are held in Chapter 3. Okay, like EMT, rigid, all those type of wiring methods, non-metallic sheath cable, all that. It says, capable of being removed or exposed without damaging the building structure or finish, or not permanently closed in by the structure or finish of a building. A good example is above a suspended ceiling is still considered accessible, okay? It's capable of being removed or exposed without damaging the building structure or finish. Okay, and it's not permanently closed in. Whereas wiring that's inside of a wall, okay, physically in the wall, is not considered accessible. It's concealed. So we just have to look at the concepts and really draw down the definition of what's considered accessible and what's considered not accessible. Okay, if I have to remove the building's finish, okay, then I have a problem. Okay, with something like that considered accessible or not, all right? Now, let's move on to readily accessible right here. So in that example that I just gave you, we were talking about the receptacle in the garage, in the ceiling for, let's say, maybe it's the garage door opener. In that scenario, if you put a GFCI in there, then that would not be considered readily accessible. And that's what 210.8 requires, that it be readily accessible. So that would be a problem. Now, can that receptacle be on with the garage circuit? Yes, but it's still, if you're going to put the GFCI protection, which is required, that's not the optimum place to put it. Why? Because if you look at the code, it would state that capable of being reached quickly for operation, renewal, and inspection without requiring those who ready access is requisite, that be whoever's getting there to service it or get to it or reset it or utilize it, to take actions such as using tools other than keys to climb over or under, to remove obstacles, or to resort to portable ladders and so forth. Now, this is a Code Making Panel 1 definition, so they own control of this. So this means that I can't put something where I have to climb over it to get to it. I have to climb under to get to it. It obstructs my ability to get to something that I need to get to, that the National Electrical Code says that ready access is required. Okay? Service equipment is a great example. Switchboard, switchgear, all those type of things. All those are good examples. Okay, GFCIs are required to be readily accessible. Okay, so all of those type of things are just understanding. Now, the one phrase that I always like to explain to people here, actions such as to tools. Let me give you another analysis here. If I have a receptacle and it is for a hydro massage bathtub, just like a Whirlpool bath, upstairs in your house, and there's an access panel, and I have a receptacle under that panel that is, to say it's a GFCI, and it is, again, within a foot of the opening, facing the opening, meets all the other rules, but it's there. If I put a door on that and I screw it in with screws, then I have to resort to using a tool, like a screwdriver, in order to be able to open it. If that's the case, then that receptacle in that GFCI, is what we're really talking about, is not readily accessible. So that doesn't meet the 210.8. Okay. Now, if it's just a receptacle and I put it in there and I actually have the GFCI, which is maybe a faceless that's out on the wall or something like that, then that's okay because that one is readily accessible. The receptacles in itself don't have to be readily accessible, but you still have other rules. For example, hydro massage bathtubs, that you have to have the receptacle facing the opening and all this kind of stuff. But you see my point? If I chose to put the GFCI in there, which was required to be readily accessible, and I use screws, then it's not considered readily accessible. Now let's take this to a different level. It says also, other than keys, right? So I could have a panel that's in the corridor of a motel hotel application, and that panel is locked by a key. It is readily accessible to those who require access to it. Maintenance people. It's not something that the tenants, people that are staying there, transient people moving in and out, and we're not saying transient as in homeless people. We're saying people that move in and out of those type of occupations or locations, like occupations. I don't know why I said that. Move in and out of hotels. They come in, they go. They come in, they go. They don't need to have access to that panel. There's no way that they can get there quick enough to turn a breaker off to result in somebody not getting shot. The breaker's going to do its job if everybody does things right, okay? Tries to do everything right. So, in this case, if the panel was locked by a key, it would still be considered readily accessible because those who need to get there have the key, right? So, kind of how you think about readily accessible, all right? And that's what it means. Now, previously, prior to the 2017 code, it said climb over, but didn't say climb under. So, we fixed all that stuff in the 2017 code, okay? 2020 code didn't bring any light to that. It's just continued it as normal. Now we see that we have definitions for adjustable speed drive. We have adjustable speed drive system. The difference in the two is, again, reading the definition is important because this is a code making panel 11 definition and they have jurisdiction over it. And it basically just says you have the drive itself and then you have an adjustable speed drive, which could be a variable frequency drive, for example, that actually is part of a complete system. So you have the adjustable speed drive, which is the component, okay? And it adjusts the actual speed of an electric motor, up or down, depending on its need. And then, of course, you have adjustable speed drive, which is a combination of motors, other equipment, maybe even integrated PLC design, whatever it is, that's a complete system, okay? So you have adjustable speed drive, which is, again, an informational note says a variable frequency drive is one type of electronic adjustable speed drive. Okay, so when you hear people give you questions about variable frequency drives, know that that is just another type of adjustable speed drive as well. One of the more important definitions that you're going to need to know in this industry is the term ampacity. We use it an awful lot on many things. Ampacity is the maximum current in amperes that a conductor can carry continuously under the condition of use without exceeding its temperature rating. Okay, so let me give you an example. In the 2020 National Electrical Code, we have the ampacity table 310.16. Now, that's a change from 2017 code, which was 310.15b16. So that's one of our changes. It's the nomenclature of the tables are going back to the older style, which meets the manual of style. Okay, so it's kind of going back. There's been a lot of cleanup work that's done in the 2020 code. So we're going to learn all that stuff as we go through this series. But ampacity, it is the maximum amount of current that conductor can carry under that condition of use. So what's the condition of use when we look at table 31016? You have a 60-degree column, 75-degree column, and a 90-degree column. Now, under the 90-degree column, you have the higher ampacity values. Under the condition of use, and that is not exceeding 30 degrees Celsius, okay, and not exceeding more than 3 current-carrying conductors, under that condition of use, that ampacity that you see under the 90-degree column can be pulled. That is the maximum current for that conductor, that it can be pulled continuously without violating that temperature rating of 90 degrees. So many people get confused when they look at an ampacity table. That is the maximum current in amperes on that table under that condition of use. Now, me and you know that that's why we end up having to do adjustment and corrections, because that condition of use in the real world is not a reality. Okay, whether it's an ambient temperature that is higher than 30 degrees Celsius or 86 degrees Fahrenheit is probably going to happen. And we also have the issue of the number of current carrying conductors that exceed 3. You have what's called mutual heating. And so we have to take those things into consideration. So as we move through this series, we're going to learn about adjustment and corrections, whether it's 31015B or 31015C, which used to be 31015B2A and 31015B3A. Quite a few changes in the 2020 code that we'll talk about. That's kind of a bonus as we go through. You'll hear about some of the changes. But ampacity is the maximum in amperes, or you could say the maximum current in amperes as it's conveyed that a conductor can carry continuously with under the conditions of use without exceeding the insulation's temperature rating. Okay, that is what ampacity is. All right. Now, another thing that we changed in the NEC was the term allowable ampacity. So when we take a conductor and we say use the 90 degrees for adjustment and correction purposes, and we'll talk about that even more when we get there, you have to understand that once you change the condition of use on that conductor, the ampacity is going to change. Heat is never good for a conductor. The number of current carrying conductors over 3 is always going to drop the ampacity. So I want to be able to start from the 90. But when you change that ampacity of a conductor, the use of the term previously allowable ampacity was kind of a misnomer. Because when you change those properties that are in 31016, you now have a conductor that has a totally different ampacity based on the condition of use. So it's no longer a condition of, is it allowable ampacity? It is now the new ampacity. That is the maximum current now in amperes that conductor can carry based on that condition of use. So it's vastly important in why I'm spending so much time on that definition to understand what ampacity truly is as we move through the National Electrical Code, because I think definitions are really important that you understand all of that concept. Next we look at is the term appliance. Appliance is utilization equipment, generally other than industrial, that is normally built in standardized sizes or types and is installed and connected as a unit to perform one or more functions, such as, but not all inclusive, things like clothes washing machines, air conditioners, food mixing, deep fryers, so forth, ranges, things like that. All of those things, dishwashers, all of those are appliances. They're utilization equipment. Utilization equipment has a definition, but think of it this way. It's a piece of equipment with a dedicated function. It's a dedicated goal of what it is designed for, okay? But you might have something that might have a motor that integrates into something that might have a heater, and they come together as a piece of utilization equipment. But if it's designed in a standardized format, then what you have is an appliance. For example, a clothes dryer. Okay, it has a motor for movement and it has heating coils. Okay, it's designed in a standardized format and it is an appliance. It is a critical component together. Now, as we move further and you start to see us do calculations, then you got to step back and say, wait a minute. Is a range as an appliance, a dryer is an appliance, but can I include them in my D rating when I have 4 or more? Absolutely not, because they stand on their own. They have their own calculations. So just understand what an appliance is, and you probably have them all over your house, okay? But a disposal is an appliance, okay? Think about it that way. All right, so we'll talk about that obviously in extreme detail. And that comes under the purview of Code Panel 17, who creates this definition. A lot of things in the code, you're going to see the word approved. And when you see approved, what does that mean? That means it's approved by the authority having jurisdiction. That is the inspector who is what's called a deputy for the building official, who ultimately is the AHJ. And they're the ones that are conveying that power to the inspector to be able to say yes or no to a specific application. So if the code says something to be approved, then the person that gives you the green tag is the one that's approving it, okay? Next is, again, we have a definition for arc fault circuit interrupter. It's a device intended to provide protection from the effects of arc faults by recognizing characteristics that are unique to arcing and by functioning to de-energize a circuit when the arc is detected. Now, this comes under the definitions purview of Code Making Panel 2. Now, what's important is to me is that you understand what an AFCI is, okay? And so AFCI is the acronym for Arc Fault Circuit Interrupter. Now, arc fault circuit interrupters come in multiple flavors, and I want to make sure that you understand what they are. So you have a circuit breaker type AFCI, okay? It goes in your panel. Now, that's looking for, depending on whether it's called a branch feeder type or it's called a combination type, okay? So the combination type is not what you think. Some people think that when it's here, they hear the word combination, that it's looking for both GFCI and AFCI protection. That is not the case. A combination type AFCI is looking for both parallel arcs, whereas you might have a hot and a neutral that has damage across them, maybe jammed in a door, a cord, and there's an arc that's not limited by the load on the end of that circuit. It is very much dependent on this damage here between the two conductors that create a parallel path for an arc to take place, and that creates a fire hazard. And so it replicates a specific characteristic that the manufacturers have tested to under UL 1699, and they have created an algorithm that they can identify this characteristic. Whether you're a supporter or not of AFCIs, they're here to stay. And so when you see a combination, it's looking for not only a parallel arc, but it's also looking for a series arc. And a series arc could be a damaged conductor that has a break in it where the current, and that's very load dependent, if you will. It means that load has to be traveling through. You have to have a load on the end for an arc to take place across these conductors. Because if there's no load, then there's no current flow. Okay, it'd be like a break. All right, so that arc is very dependent on the load. But if you have a load that's going pretty consistent and you have that arc, it can generate just as much heat, and any material around it, if it's combustible material, it can pyrolyze it and it can cause it to start a fire. So early on, we didn't think those were a problem. So your branch feeder type of AFCIs are only looking for parallels. They're not looking for series. So the combination came along and said, okay, we're going to look at parallels and we're going to look at series. And we're going to try to identify both. And they're not without what people would like to call nuisance tripping. Sometimes you're going to find that it's not so much a nuisance trip. It's something's going on downstream that's causing it. Maybe a neutral and a ground are touching or something's happening. And it's causing the system to activate. In fact, I look at AFCIs as diagnostic tools, if you will. Because many of them have gotten very sophisticated in how they identify the circuit problem due to the characteristics. Okay? Now, there's some people that believe that GFCI or GFI, which are two different things, has to be involved in the system for it to detect arcs. I disagree, but if it was there, is that an enhancement? Absolutely, it's an enhancement. But even if a combination AFCI, the breaker, we're at the breaker now, even if that has AFCI protection and it had GFI protection, usually like 20 milliamps or greater, not necessarily the 5 milliamp nominal for a normal GFCI, if it had the GFI feature in it, they feel that that makes it activate better, okay? And you know what? It does have some enhanced benefits to it, but the standard for AFCIs doesn't require it. So as long as the manufacturers test their requirements, The manufacturer knows best, and you follow their rules. Whether you like it or not, you're going to have to substantiate why you don't like it. Also, I should mention this. If you have problems with AFCIs for whatever reason, go to afcisafety.org, afcisafety.org, and you can submit a report or a problem that you're having, and those manufacturers will respond quickly because this is actually run by NEMA. So get out there, but for the most part, I've installed a ton of AFCIs and never had a problem, and I've had them actually stop an issue that you couldn't see. All right, so I'm a big fan of them because I think it's a small price to pay for safety. All right, but enough of that soapbox. So AFCIs. Now, that is the branch circuit kind. I mean, the breaker kind. Now, remember what we said? There is also a breaker called a feeder branch circuit AFCI. Again, that's only looking for parallels. It's not looking for series, okay? But the code now allows you to continue to use them as long as when you get to the first receptacle in the system, then you have the protection downstream, an AFCI device. And that AFCI device will bring back the series check upstream. Okay, so there's different rules in 210.12 that you can follow, but you have the branch feeder, and it's going to have some caveats in how you can still use it, okay, because you're only going to get parallel protection. You're not going to get series protection. Or you have the combination, which is giving you series and parallel protection, okay, well, parallel, series protection. And then you've got another type, and that is what's called a branch circuit device or receptacle type of AFCI. Okay? And that actually installs at the very first receptacle in the circuit, and that is looking for parallels and series upstream, parallels downstream. You use it in conjunction with a branch and feeder, and you can get double the protection. But there's certain applications where you would use a receptacle type AFCI. And they are available. People still question why they're available. They definitely are available under 210.12. Now, again, I'm just giving you the 30,000 foot view. We'll cover this in more detail when we get to 210.12 and look at all the aspects and where you can install it. But we're just kind of touching the 1,000. I want to take the time in this series to cover definitions truly in depth. Okay? Now, let's say, so then there's another type of AFCI, which many people refer to as what's called a dual function. Now, what is a dual function AFCI? It means that when you hear the term dual function, it tells you that it has both AFCI protection in it and it has GFCI protection in it. Not GFI, or it's GFCI, or not GFP, it's GFCI, just like the receptacle that you would have inside of on your kitchen counters or in your bathroom. Okay? Now, that means that if I put it in the breaker, in the panel, then I'm going to get the benefits of GFCI protection, and I'm going to get the benefits of AFCI protection. Now, take kitchens, for example. Kitchens under the 2020 code, for example, are going to require that you have AFCI protection and GFCI protection. They both work together. So I could go with the breaker. I could get a dual function that does both, and then I don't have to put any GFCIs on the counter because it already covers it. Or I can put an AFCI combination that is getting me the series and parallel arc protection that's required by today's code. And I can go to the first receptacle on the counter and put a GFCI device in that receptacle. They both work together, okay? Or I could put a dual function in, and that will cover everything. Or I can put a combination in at the panel breaker, and then, again, go to the first receptacle and put a GFCI receptacle. They both work fine together. It's not a problem. Okay? The technologies are different. One's looking for characteristics, and one's looking for leakage current. It's not coming back on its intended path. Okay? So you have all these options with AFCIs, but they do function and they work. Okay? Now, I'm not going to cover every definition, but I'm going to cover some that I feel are important. All right, so this is a new one that's here for the 2020 NEC, and it's called an attachment fitting. All right, so what is an attachment fitting? It is a device that by inserting into a locking support and mounting receptacle establishes a connection between the conductors of the attachment utilization equipment and the branch circuit conductors connected to the locking support and mounting receptacle. Okay, and there's an informational note, but I want to explain kind of what this is that we're talking about. Now, these are what came into the code back in 2014, and it started making its way into 314, but we didn't have a good definition of it. So let me explain. I run my wiring to a junction box, or no, let's say I run it to a light box, fan box, in the ceiling of a room. I run my wiring. Maybe it's non-metallic sheath cable. I run it there. Now, this is a device that is a receptacle, but it mounts up in the actual box, and you have a fitting that mounts to the luminaire. That's your attachment fitting. And so we have this receptacle, which is specifically the reason we had to change the definition of receptacle last cycle in 2017, because it actually mates with this attachment fitting. So this attachment fitting, you'll take the wires from the fan, you're connected to it, and it has a middle stud. And it literally, once you install the receptacle up in the lighting outlet box or the fan box, it literally will mate together. And so this fitting is the attachment fitting that will connect to this receptacle, and they're designed together. They work as a tandem unit, and that is allowed in the National Electrical Code. Okay, so that's what that actual product is. All right, so then it talks about it down here and says, look, informational note, just to give you some clarity. It says an attachment fitting is different from an attachment plug because no cord is associated with the fitting. And you know what I'm saying? An attachment plug goes on the end of a cord. This doesn't go on the end of a cord. So it's different, okay? And it's going to, in conjunction with the receptacle, support the weight, okay? And we're not talking just like a duplex receptacle. It is a different, we'll cover that when we get there, but it is a combination mechanism, okay, that goes together, and that's what the attachment fitting really is. So let's read it here. It says, an attachment fitting in combination with a locking support or mounting receptacle secures the associated utility equipment in place and supports the weight. So in this case, it's a ceiling fan that this attachment fitting connects to. It might even come by the manufacturer, or it's a separate component, and it actually will mate to the receptacle that goes up into the box. So the utilization equipment connects to this fitting that connects to the receptacle, and by its design, it supports the weight, okay? So it's a system, okay, and you buy it that way. All right, let's go on. Again, we pretty much know an attachment plug. Authority having jurisdiction, it's important that I talk about this so you have understand authority having jurisdiction a little bit better. It says an organization, office, or individual responsible for enforcing the requirements of the code and standard, or for approving equipment, material, and installations, or a procedure. Now you have this kind of an informational note here that goes into a lot of understanding that sometimes it might not just be the municipality where you're doing the work. If you're on a military base and they're utilizing this document here, the National Electrical Code, then they are somebody on that base is the authority having jurisdiction, because that's a minimum safety standard. So they're the ones that are going to have to approve something, give an okay for a procedure, okay? Give their blessing. So it doesn't always have to be a jurisdiction, okay? It could be, again, a military base that is outside of the scope of the NEC when it comes to municipality inspection, but they're doing the work inside of the facility in accordance with that document. They've adopted that document for their safe installation practice. Now somebody has to take up the responsibility of being the AHJ. It could be, again, the organization. It could be one individual in there. Again, it could be any number of people that have that role inside of the association, but they have to take that responsibility. Now, it's easy for municipalities because that ends up being the building official who will assign deputies, inspectors, or supervisors to go out and make that call on their behalf, okay? So that's kind of an AHJs in a nutshell, and you'll see that all through the NEC where we talk about that use of AHJ. Remember, they're the ones that have the approval power on certain types of equipment, whether it meets a certain standard, whether the material is acceptable for a certain condition of use. And there's sometimes you have boxes that aren't required to be listed, but they're being put in an application where it's going to require approval. And so the inspector says, give me information on the box. Give me information from the manufacturer. Show me something that says it's made for this condition of use before I'm going to put my green stamp on it and tell you that it's okay. That's the concept of an AHJ, authority having jurisdiction. Okay? All right. Automatic, anything it references in the code, automatic means it kind of happened without us having some kind of intervention, like we having to flip on something. It's automatic. It just goes. Bathrooms, here's an important one that I see people get wrong on an exam, is the definition of bathroom. Many people go and say, and on one of my exams in my Fast Tracks program, it'll talk about, they'll say, what's considered a bathroom? They'll say it's a toilet and a urinal. And that is not what constitutes a bathroom. That might just constitute a room with a toilet and a urinal. You have to have a sink first for it to qualify as a bathroom. And we define bathroom because throughout the code, we make references in 210, 210.11c. We make different references to the term bathroom and what we can do in a bathroom. We needed to know what a bathroom was and what constitutes a bathroom, because we could have an area that was just maybe has a shower and a toilet, and it not necessarily a bathroom, but now it requires the ability to have receptacles in there in those areas. And that's when 210.8 will start kicking in and require GFCI protection, because now we've added things like shower stalls and tubs and that into areas that might not actually qualify as a bathroom. But just remember, in a bathroom, I have to have a sink or a basin, whatever you want to call it, depending on where you're at in the country, a sink, but I have to have one or more of the following. I have to have at least a toilet, a urinal, a shower, a bidet, or a similar plumbing fixture. Now, why do we say or similar plumbing fixture? Because new technologies are coming out all the time, and people are making all kinds of things that are used in a bathroom. So when we say similar plumbing fixture, if it's similar to one of the activities that you would use while you're using a toilet or a urinal or a tub, then it can be a product that comes out that might be in that gray area. But if it serves one of those functions, that's what it's kind of used for, the same intent, then it's going to be the same as whether it would be a toilet, a urinal, or tub, or shower, that type of concept, okay? If it serves the same purpose. So that's pretty much a generic catch-all, okay, for technology advancements. Yes, the plumbing industry still has advancements, okay? It's not just hot on the left, cold on the right, and stuff flows downhill or something like that, okay? You know what I'm talking about. All right, so there you go. So we have that definition of bathroom that we want to cover. Obviously, we have the definition of bonded and bonding. Now, this is important as we go through our journey and you understand bonding and the concept of bonding things together. There's a concept of, we see bonded, and to meet bonded, so someone to be considered bonded, you have to do the act of bonding, okay? So bonding is kind of the process, okay? That's kind of the action that you do, okay? And when you do it, everything is considered bonded. So bonding is the practice, bonded is the result. So in this case, a reliable connection, connected to establish electrical continuity and conductivity. If me and you hold hands, the act of us reaching out and holding hands and making that connection is the bonding. The moment that we complete that task and we complete that continuity and that conductivity, we are now past tense. We are bonded. We are bonded together, okay? So that's the concept of making you understand that there's a practice of doing something, and then once it's done, it's considered bonded, all right? That's getting pretty deep, but you understand it. So we have what's called bonding conductors or jumpers. It is a reliable conductor to ensure the required electrical conductivity between metal parts required to be electrically connected. And critically important definition to understand. And we won't go over every definition because I don't know that's necessary, but we'll go over a lot of them, and this will take time, but these are important. Bonding jumpers, for example, let me talk to you about that. So let's say I go from a panel and I'm going down to a ground rod. That is a grounding electrode conductor, okay? But once I get to that rod, if I have the second rod that's at least 6 feet away, and now I'm going over to that, from that first rod to that second rod, that is called a bonding jumper. From the first one to the second one, Okay, and it's not required to be any larger than the grounding electroconductor that came to it if both of those electrodes are identical and they both require the same size or the minimum size required grounding electroconductor. So I could have, let's say, a 6-gauge copper run into a ground rod, and I stop there on a clamp, and I add a second clamp, because I can't put it under the same clamp unless it was designed for it, and most like acorn clamps are not designed for that. Then I add another clamp, and I jump over to the second ground rod, let's say. That's a bonding jumper between the first one to the second one, okay? That's not a grounding electroconductor. Many people think that the grounding electroconductor has to be continuous through the first acorn clamp and then to the second one. Can you do that? Absolutely. If you want, it'll save you having to buy 2 clamps. You can only use 1 clamp. But can I stop at the first one? Absolutely, because that is your electrode. I go from that one to the next one. That is called a bonding jumper. Okay, and it has to be terminated right, and it's connecting those parts together. Okay, now we have other types of bonding jumpers. We have supply side bonding jumpers, and we have definitions for that we'll see in a minute. Okay, we have main bonding jumpers. Just remember the generic catch-all term for connecting these parts together, these metal parts, is called a bonding jumper or a bonding conductor throughout the NEC. And then when we're more specific, we'll talk about it. We'll say that something's a supply side bonding jumper, or we'll say it's a system bonding jumper, or we'll say it's a main bonding jumper. We'll be very specific when we need to be specific. Okay. Next we look at, you see here is equipment bonding jumper. And equipment bonding jumper is the connection between 2 or more portions of equipment grounding conductors. Okay. So here's a great example. If I come to a junction box that's metal, and I bring all of my equipment grounding conductors in there, whether it's bare or insulated, I bring them all to a box, and I've got a receptacle or a switch. Let's say it's not a self-grounding type receptacle, or it's not surface mount type mounted box, and I need to have a bonding jumper. So where I'm making connection from my equipment grounding conductors to bond the metal box or to bond the device, that would be an equipment bonding jumper. It's not an equipment grounding conductor because that was what's ran with the circuit. But it's an equipment bonding jumper that's making that intimate connection between the device or whatever I'm trying to connect to bond it, okay, and the equipment grounding conductor. So it's making that intimate connection between each one of them, okay? So that's what an equipment bonding jumper is, okay? The next thing would be a main bonding jumper. And a main bonding jumper is located in the service equipment. Now, there's been quite a few changes to the National Electrical Code, and we need to understand that a main bonding jumper is very specific. A main bonding jumper is vital to an overcurrent device being able to operate in service equipment. You have to have that main bonding jumper installed. Now, downstream, remote panels, people call sub panels or a remote distribution panel, however you like to call it, it's downstream of the service. You're not going to have a main bonding jumper, okay? Now, you might use the main bonding jumper if it's a screw in order to make a connection from, say, a bus to the enclosure, but the neutral or the grounded conductor cannot be connected to that main bonding jumper screw, which is still not a main bonding jumper. It's just the screw that you would have used it if that was service equipment. Don't let that get confusing to you. Downstream, it's just there and you're going to use it. Then the grounded conductors need to be isolated. They need to be floating, not in contact with the metal enclosure. But that equipment grounding conductor bus can be connected. And you might use the screw that was used as a main bonding jumper in a service panel downstream only to connect that bus to the enclosure, but not to connect the neutral bus to the enclosure. Don't worry. When we get to 250.24a5, we'll talk about that, and I'll give you extreme detail that we look at that. In fact, we'll even dabble in the book and look at the grounding and bonding book with a lot of images when we get there, okay? All right, the next type of bonding jumper is the supply side bonding jumper. Oh, I also should state this as well. Check this out. Main bonding jumper. I don't want to leave this topic here because I said services, but I want to talk to you. There is a different application as well. It says the connection between the grounded circuit conductor and equipment grounding conductors or the supply side bonding jumper or both at service equipment. So we could have a supply side bonding jumper that's bonding all of the enclosed, the raceways that are come in that contain service conductors and things like that. And we want to make sure that that connection is being made, and it's all being connected together and tied together from the enclosure, everything, with a main bonding jumper application. Okay, just tying everything together in your service. Now, we'll get more detail as we get further on, but just kind of giving you the basic concepts of the definition. Now, new for the 2020, not new in the sense that it used to be up in 250.2. Now it's been moved because, again, obviously supply-side bonding jumpers are used all over the place. Transformer applications, all their separately derived applications are used. So we have to use this definition now. So we're going to move it to 100, okay? And I'll remind you, it stays under the control of Code Making Panel 5, but it's used in more than one article, so it ends up being here. So, supply-side bonding jumper. It is a conductor installed on the supply side of a service or within a service equipment enclosure or for a separately derived system that ensures the required electrical connectivity between metal parts required to be electrically connected. I need to tie them together. So let me give you some examples. In a service, I've got raceways coming in that have service conductors in them. And whether they're metal raceways, let's say. And I need to do assured bonding. I need to do something extra in 250.92 for bonding, okay? So you got all those rules in 250.92, 250.90, dealing with services and whatnot. So I got to bond it. So since it's on the supply side of the service disconnect, it's called, that bonding that we do is called a supply side bonding jumper. Now, we all know we're going to size that based on 250.102C, but we need to know why we're doing that. And so a supply side bonding jumper doesn't have the luxury of having overcurrent protective devices ahead of it. So we size it differently than we did an equipment grounded conductor, which uses 250.122 based on overcurrent device sizes. This is different. There's nothing that we can rely on the supply side. Okay, so we have to size it based on the size of the conductors that are supplying that piece of equipment. So that's your service example, and all of that, whether you do a single loop or you do individuals. And we'll talk about all that when we get to 250.102C1. We'll talk about all that. But just understand that's where it's used. Now, where else is it used? Well, if I have a transformer on a property and I'm feeding a panel that's on the secondary, and I've got secondary conductors from the secondary terminals of a transformer, then unless I'm running a metal fixed raceway, which could be utilized as a supply side bonding jumper, because I need to connect the panel and that secondary transformer, I need to connect the metal of each together. If it's a non-flexible, then we're okay if it's metal and it meets the requirements of 250.118 as an equipment grounded conductor, one of those type of fixed raceways. But if it's FMC of a certain size and length, or if it's PVC, something like that, then I need to make that connection. So I'm going to pull what's called a supply side bonding jumper in it. And I'm going to make that connection over to the actual panel that's being fed from the secondary of a premise wired transformer. Okay? So, I mean, that's what it's called. So it's really supplying this bonding jumper between the transformer and that panel. Okay? So that's the kind of the concept with the supply side bonding jumper. Again, you're going to size it as well based on the conductors that are derived. We hear the term derived. That means conductors that are originated, created, derived from the secondary side of a transformer, right? So, and we'll cover all that, trust me, as we move forward. You're excited because we're going to cover a lot of topics. This is going to be a long series, but you're going to get a lot out of it, trust me. All right. So the next thing we look at is a system bonding jumper. That is the bond that takes place in things like generators, if it's a separately derived system, and we'll talk about that when we get to that definition so I can be more clear. I don't want to eat up time. But that is the connection between the grounded conductor and the equipment grounding conductor connection point in a generator, if it is truly separately derived. That's a key thing we'll look at when we look at that term. But it also is utilized in transformers, because transformers are also separately derived systems, and you have a primary and you have a secondary, okay? But on the secondary, I need to make a connection from the XO in order to make it to the case. And in order to do that, I would install a system bonding jumper. And so you size system bonding jumpers, again, based on 250.102C. And so we'll talk about that when we get there. You just need to understand where that takes place, okay? So if you look at the definition, it says the connection between the grounded circuit conductor and the supply side bonding jumper, okay, if that's to take place, if that happens to be in a transformer application, but, could be in a generator application, it says, or the equipment grounding conductor, or both at a separately derived system, okay? So it's really serving as the linchpin between the grounded conductor and a supply side bonding jumper, or the grounded conductor and an equipment grounding conductor, because it could do either or at separately derived systems. Of course, we need to understand what a separately derived system is, and we're going to do that. And I'm going to give you some real good examples of what determines a separately derived system as we move through this, so that you have the knowledge to share it with other people. The next thing is, obviously everybody knows what a branch circuit is. Those are the conductors from the final overcurrent protection device, like in your panel, that breaker that goes out to a receptacle. That last breaker, that circuit that's running out to that device, that outlet out there, whether it's a lighting outlet or whether it's a receptacle outlet, that is called a branch circuit. Okay, so it's from the final overcurrent device, that circuit breaker that's in the panel, out to the actual outlet, and that's the circuit conductors. That's called a branch circuit. Okay. Now you have also in that same, that's your general term. You have what's called appliance branch circuits, and that is where it's running out to appliances. So any branch circuit that supplies energy to one or more outlets to which appliances are to be connected, and that has no permanently connected luminaires that are not part of the appliance. Okay, so if I'm running this out, so I have small appliance branch circuits. Those receptacles, for example, are there for appliances to be plugged into those outlets. Those just happen to be receptacle outlets, okay? So that's going to be an appliance branch circuit. Usually in the code, you cannot have any other outlet on that small appliance branch circuit. But I could run this branch circuit to a specific appliance, and we saw the definition of an appliance, like say to the dishwasher, and that is its function, okay? That would be a branch circuit to that specific appliance, okay? So you get the concept here. Then you have what's called general purpose branch circuits. These general purpose branch circuits are all those branch circuits that you're running throughout the dwelling, let's say, or in a commercial building to the specific demanded receptacles that might be on the drawing that you're installing, okay? They're just general purpose. They're there. When I do a load calculation on a dwelling, for example, all the general purpose receptacles around the room are all covered in my general lighting and receptacle calculations, which under the 2020 code is now under 220.14J. It used to be 220.12. Subtle changes in the 2020 code that we're going to make you aware of. But the general purpose is a branch circuit that supplies two or more receptacles or outlets for general lighting and appliances. Okay? So, another important subtle thing here. Notice it says a branch circuit supplies two or more receptacles. A duplex receptacle, normal receptacle that you install all the time, that is two receptacles. Two single receptacles. They're just on one strap or yoke. But that's still two receptacles. Real important when you start looking at other aspects in the code that talk about where you might have something that says individual branch circuit, like when you get in the kitchen, you're allowed to deviate, let's say from, let's just use a refrigerator, which can be on a 15 amp circuit instead of the 20 amp circuit, as long as it's an individual branch circuit, okay? That means that a duplex receptacle is literally two receptacles, okay? So, and I might put something that's individual. I'm supplying only one piece of utilization equipment. So it would be argued that that would be what's called a simplex receptacle, just for that piece of equipment, okay? Very subtle, but you need to understand it. Next, individual branch circuits, okay? Now, people use the term dedicated branch circuit. Does not appear in the National Electrical Code. It's an individual. If you're running something to one piece of utilization equipment, then it is an individual branch circuit, okay? A refrigerator is an appliance, but it is also a utilization equipment, okay? We know this because when we look back up here at appliance, and we go back here to appliance, you notice that appliance, it says utilization equipment. but we're very familiar with a refrigerator being an appliance, right? So in our world, that is being run to it. So when it says here that it says a branch circuit that applies only one utilization equipment, that's the only thing that can be on that for that equipment. And if I'm hitting a receptacle, for example, or hardwiring it, that could be an individual branch circuit, but I have to ensure that that is the only piece of equipment that can be utilized on it. And that's where many people will argue that if you're going to use the allowance for the refrigerator, for example, I use that as an example, in the small appliance branch circuit, which typically requires the refrigerator to be part of the small appliance, believe it or not. But if you don't want it to be, the code allows you, for example, to have an individual branch circuit to an appliance like a refrigerator, and it could actually be protected by a 15 amp circuit and a 15 amp overcurrent device as well. Well, if you do that, I have to ensure that that's the only thing that's going to be powered by that individual branch circuit, okay? So that might result in a single receptacle, and that is one receptacle. Whereas, again, duplex is two receptacles. Just subtle, but it's good for you to know, okay? All right, multi-wire branch circuit. Now, a multi-wire branch circuit is extremely important for you to understand what it is. So we're going to spend a little time on it. A multi-wire branch circuit is, let me give you an example, a 14-3 or a 12-3 that's run. Let's say I'm in a kitchen and I want to have two small appliance branch circuits and I'm going to run a 12-3 NMB. Or if it's commercial, I can run a 12-3 MC cable, whatever. It's going to have a black, it's going to have a red, and it's going to have a white. And if it's MC, for example, it's going to have an equipment grounding conductor. Could be insulated, could be bare. Code allows for either. The standard for MC allows either or. If it's MC cable, if it's NMB, then it's probably going just like the non-metallic sheath cable. It's going to be more than likely bare. And so in that scenario, a multi-wire branch circuit, I have a red, a black. The white is carrying the imbalance, okay? That's the imbalance from the black and the red. So when we're doing a multi-wire branch circuit, it's so important that if we're doing it, that we utilize things, and we'll talk about it when we get into 210, that we have to understand that I have to make sure that the red is on one phase and the B is on a different phase. Now, in a panel, it alternates. So a single phase panel, 12240, it goes A, B, A, B, A, B, A, B, A, B. So if I use a two-pole breaker and I put it in the panel, I'm ensured that if I use a true multi-wire branch circuit, which I can supply two separate circuits with it, both are considered separate circuits, but they're sharing a single cable assembly, then, or I wire it that way inside of a raceway that way, where I'm sharing the neutral, then realize that since the black is on one phase, the red's on the others, that in the sinusoidal waveform of AC current, alternating current, that if I have 10 amps on phase A and I have 10 amps on phase B, because they're locked in there with a two-pole breaker or two single-pole breakers with an identified handle tie that makes them have to be connected together, okay, and has to be identified for its purpose, then what happens is when I got 10 amps on A or the red and I have 10 amps on B, I've got 0 on the neutral because there's a cancellation effect that takes place. So I have 10 amps on this portion of the waveform, 10 amps on this portion of the waveform. They cancel out and the neutral sees 0. If I have 10 amps on the red and 5 amps on the black, what do you think you see on the neutral? You see the imbalance, and that would be 5 amps, okay? So 5 and 5 will cancel out. You have 5 remaining because one was at 10 and one was at 5. Awesome phenomena that happens in that scenario, but that's why you can get away with multi-wire branch circuits, okay? And they, both of them, if you wire them right, get treated like separate circuits, okay? All right, so that's kind of a multi-wire. Of course, we'll get into the terminations of that and everything as we move further on into our journey, okay? All right, and the last one for this episode is we're going to talk about a building. Why is it important for this definition of a building? It's important because if I'm doing a building, and let's say I have a strip mall, I have to understand whether or not how many services I can bring to a building, how many feeders I can bring to a building, because generally the code says I only bring one to a building. But I have some caveats, some things that I'm allowed to do. So if I have a strip mall, a strip building, let's say, that I have six units. And each one of those units are separated by a rated wall, not a firewall, a rated wall, okay? Whether it's just 2-hour rated, 1-hour rated, whatever. Then I literally have only one building. And so I can only bring one service to that building. And it's going to play a part in how we design that building, right? Now, if I put firewalls between each one of those units, then each one of those units stand alone as theoretically a building. So I can have a service, if you will, to each one of those separate units. That becomes 6 separate buildings. And usually, when it comes to zoning in a jurisdiction, it's going to have 6 different addresses, all right? And it's difference where you have one address and then you have unit A, B, C, D, and E, and F, whereas you have a unit that is 1601, 1602, 1603, 1604, because they're separate units, okay? They're separate buildings, okay? When I'm designing something, I have to take all of those things into account, okay? And that's why it's important for me to know what a building truly is, okay? So when you look at the definition, it says a structure that stands alone, that'd be just one building by itself, or that is separated from adjoining structures by firewalls. If I have that strip of buildings, of spaces, and again, it's not firewall separated, then that's just one building. I put firewalls between them, and they meet the requirements under the International Building Code as a true firewall. Goes from the foundation up through the ceiling, and it has its adequate rating as a firewall. With the lack of penetrations that can put the firewall integrity in question. Again, that's a building code thing. Then as long as I have that separation, then I've got 6 different buildings. But if I don't have firewalls, then I have just one building with 6 different units in it. And that I have to take that into consideration when I'm designing my service, when I'm designing maybe a feeder if it's being fed, because I have limitations on how many services or how many feeders that I can take to a building. And so this is why it's an important thing for us to understand what these definitions are. And that's why we have to understand what a building is. So hopefully you got something out of this first episode as we start to dip our toe into Article 100. So hopefully you're ready for the next episode. We'll go into more detail. But thanks for watching, and thanks for being a part of our Patreon program. Till next time, stay safe, and God bless.
Shut up and sit down.